Okay, these are some problems from section 4.2, and we wanted to find the relative extrema, any relative extrema. Then we wanted to find the intervals on which the function is increasing, that was b, and decreasing c. So first of all, in order to find the extrema, we want to find the critical points, and we'll do that by taking the derivative. So we take the derivative, this is our function, f of x, which equals 5x minus x squared. We take the derivative, that's just going to be 5 minus 2x. Now remember, the critical points are where the derivative is either equal to 0 or undefined. Well, this is just a straight line, so it's not going to be undefined. So where will it be equal to 0? Well, I just said the 5 minus 2x equal to 0. I get 5 equals 2x, so x equals 5 halves, or 2.5. So I put this on my first derivative line. Okay? Now once I do that, okay, I guess we can zoom in just a little bit here. See a little bit closer there. It's better. Okay. All right. So once we do that, okay, we try to check to see this is my critical point. So I mark my critical point, 2.5 or 5 halves on the first derivative. And I just check it at 0. If I put 0 in here, it's positive. And if I put 3, which is on the other side of 2.5, I get 5 minus 6 is negative. So we can see that we do change at 2.5 or 5 halves. So that I know that I do have a relative maximum because I'm going from positive to negative. You can see the curve goes like that. Okay, so you wanted to find what the value was of the function at 5 halves, so you'd have the point. So we put 5 halves into the original function. 5 times 5 halves minus 5 halves squared, 25 minus 25 fourths, which ends up being 50 fourths minus 25 fourths, which is 25 fourths. So this is your point. 5 halves and 25 fourths, so we have a relative maximum at this point. So we say the relative maximum at 5 halves, 25 fourths, because f prime changes from positive to negative there. Okay, so that's our relative extrema. Now remember, since f prime is greater than 0 on this open interval, we say that f of x is increasing. F of x is increasing. Since the derivative is positive, the function is increasing on the half closed interval, so from negative infinity to 5 halves, and we would close that over here. I hope you can see that. It's a little shorter room there because the derivative is greater than 0. Now that's because it's positive, it's increasing obviously. Since the derivative is negative on this interval, 5 halves infinity, all right, since it's negative, that means it's going downhill, then we'd say f of x, the function, is decreasing on the interval 5 halves infinity. And that's always open. Infinity is always open. So this is the derivative. The derivative increasing, derivative greater than 0 implies increasing. The derivative less than 0 implies decreasing. Okay, so I hope you can see that. Greater than 0, increasing, less than 0 or negative, decreasing. All right. Okay, let's take a look at number 17. Here's number 17. And this is a little bit easier because of the situation. If we take a look at h of x equals 2 over x, which is 2 times 1 over x. Remember the derivative of 1 over x, that's one of the ones we have to remember, is negative 1 over x squared, so that's negative 2 over x squared. And this is going to be interesting. We check for critical points. That's when the derivative is 0. Well, it's only going to be 0 when the numerator is 0, and that's not going to happen, so it's not equal to 0, and it's going to be undefined. It will be undefined when the denominator is 0 or when x equals 0, so I put my point in here. And if we notice, this part here is always going to be positive because x squared would be positive and 2 is positive. So with a negative in front of it, my fraction will always be negative. I could put some values in here. It doesn't matter. It's always going to be negative. So therefore, I have no relative extrema. Okay? The b part, where is it increasing or what intervals it's increasing? It's increasing nowhere because it's always decreasing. Or 0. So because it's kind of like it probably has a shelf. Well, it doesn't have a shelf. What's happening is it's one of these ones which flips, so it's going down like this, asymptotic, and then down like that. So it's one of those things. If you graphed it, you would see it's going down like this and then down like this. So it's always decreasing. Not really a shelf. Okay? So it's decreasing from negative infinity to 0. And we include the 0 point, and to 0 from 0 to infinity. because the derivative is negative. So since h prime is negative, it's decreasing. Okay? All right. And again, if you graph this, you would see it's going like this and then like that, always decreasing. Okay, let's take a look at number 19. This is another little straightforward one because of the situation. If we look at 19, f of x equals e to the 2x. So the derivative is 2 times e to the 2x. And this is never equal to 0, and it's never undefined. It's monotonic, and it's always increasing. It's an exponential function, so they're always going up like this. So therefore, there's no relative extrema. Since f prime is always positive, f of x is increasing, always, from negative infinity to infinity. Again, it's a monotonic increasing function. Where is it? That's where it is increasing. Where is it decreasing? Nowhere. So it says the intervals, it's decreasing none. Okay? And let's take a look at number 21. So number 21, again 4.2 homework. This is y equals 4 minus the square root of x squared plus 2. Now remember, we have a restriction on our domain here that this has always got to be greater than or equal to 0. I should say greater than or equal to 0, pardon me there. So therefore x has got to be greater than or equal to negative 2. So that's my domain, negative 2 to infinity. So remember that when we're talking about this. Okay, and then we take the derivative. We take the derivative. The derivative of 4 is 0, and then we can use our square root rule, negative 1 over 2 times the square root of x squared plus 2, and the derivative of this is just 1. Okay? All right. Well, again, it's a fraction. The numerator is never 0. It's just 1, so it's not going to be equal to 0, but it will be undefined when the bottom is 0. Okay? And actually, it's undefined when it's less than or equal to 2. I'm sorry. When x plus 2 is less than or equal to 0, it's actually undefined. So we can actually solve and get less than or equal to negative 2. So it's undefined, less than or equal to negative 2. Well, what's happening is we actually have an endpoint, so that endpoint is over here. And then if we look at the derivative over here to the right of negative 2, this has always got to be negative because this is always positive. So I probably should have marked that in, that since this must always be positive, it can't even be 0, it's got to be greater than 0. So it always has to be, x must be greater than negative 2 for it to be defined. Okay? This is where it's undefined, so it's defined only when x is greater than negative 2. Therefore, this is always going to be positive, and since there's a negative in front of it, that's going to make it negative, so it's always going to be negative. That would be actually y prime. I can call it f prime also, I hope. And you could try any number, but it doesn't matter what number you could try. It's always going to be negative. So therefore it's decreasing. And what happens is, since we have an endpoint, remember, if the values to the right of the endpoint are less, the endpoint's a relative maximum. And that's what's happening, because since my endpoint here is at negative 2, and after negative 2, the derivative is negative, which means it's decreasing. That means all the numbers to the right of negative 2 are smaller, so negative 2 is a relative maximum. So we can put the value for negative 2 back in the function y. Y of negative 2 equals 4 minus negative 2 plus 2. Well, that's just 0, so it's just 4. So negative 2, 4 is an endpoint of the domain of f of x equals y, or y equals f of x. And since the derivative f prime is less than 0 on negative 2 to infinity, and negative 2, 4 is a relative maximum. And you can see by the graph here, by our number line, what's happening, our derivative line. Here's my point, and the slope is, the function is going down after or to the right of the left endpoint. So since it's descending to the right of the left endpoint, then the left endpoint must be a relative maximum. Okay? And all this over here that's undefined, these are there's nothing going on to the left of negative 2. All right? So Where is it increasing? Well, the question in letter B, what intervals is it increasing? There's nowhere it's increasing. Where is it decreasing? It's decreasing here because the derivative is negative. So since the derivative is negative, the function is decreasing on this interval. Okay? Hope those help.